Hello class, today we're continuing on with chapter 9, measurement. Today we're looking at 9.3, measuring weight and temperature. Our objectives today are to apply metric prefixes to units of weight, convert units of weight within the metric system, use relationships between volume and weight within the metric system, use dimensional analysis to change units of weight to and from the metric system, and understand temperature scales. So let's look at weight and mass and the difference between the two. The weight, the measurement of gravitational pull on an object. The mass is the measure of the quantity of matter in an object, determined by its molecular structure. Note, in this section, we will treat mass and weight as equivalent and refer strictly to weight. Now, units of weight, the English system. 16 ounces equals 1 pound. 2,000 pounds equals 1 ton. Versus the metric system. Once again, with the metric system, we're sticking with the same prefixes here. We have kilogram, hectogram, decagram, base unit of gram, decigram, centigram, and milligram. Okay, along with the same meanings they've had before, rendering from 1,000 grams to 100 grams to 10 grams to 1 gram to 0.1 gram to 0.01 gram to 0.001 gram respectively for kilo through milli. We change them in the same manner we've changed them in the past by just moving the decimal place. So if I wanted to convert 950 milligrams to grams, then all I would need to do is I would need to start at the milligram and move 3 places to the left to get to grams. So if I'm moving 3 places to the left, the decimal should come in front of the 9 now. So as you can see, 950 milligrams is the same as 0.95 grams. 1 kilogram of water has a volume of 1 liter. So 1,000 centimeters cubed equals 1 decimeter cubed equals 1 liter equals 1 kilogram. There it is. So volume and weight of water in the metric system, 1 centimeter cubed equals 1 milliliter cubed. 1 centimeter cubed equals 1 milliliter equals 1 gram. 1 decimeter equals 1,000 centimeters equals 1 liter equals 1 kilogram. 1 meter cubed equals 1 kiloliter equals 1,000 kilograms, which is 1 ton. Okay. An aquarium holds 0.25 meters cubed of water. How much does the water weigh? Alright, solution here. We use the fact that 1 milliliter cubed of water equals 1,000 kilograms of water to set up our initial unit fraction. Okay, so going back here, I'm looking at 1,000. So we're going from meters cubed, and we want to know how much the water weighs. So we're going from meters cubed. So we're starting here. We want to figure out how much it weighs here. So 1 meter cubed is 1,000 kilograms. Okay, 1 meter cubed is 1,000 kilograms. That's our conversion here. So we're using the fact that 1 meter cubed of water is 1,000 kilograms of water to set up our unit fraction. So 1,000 kilograms over 1 meter cubed is our unit fraction that we're going to use here. So 0.25 meters cubed equals 0.25 meters cubed over 1. That's our initial fraction. And we're going to multiply it here by this unit fraction so that I can cancel out, as you already see done, these meters here, meters cubed. So 0.25 times 1,000, the meters cancel out, I'm left with kilograms. So we see that 0.25 meters cubed is equivalent, after our conversion here, to 250 kilograms. So 0.25 meters of water weighs 250 kilograms. Okay. Now, of course, we're going to look at our conversion from English to metrics. So 1 ounce is the same thing as 28 grams. 1 pound is the same thing as 0.45 kilograms. And 1 ton is the same thing as 0.9 tonni, with an E, I guess. Tons in the English system is a capital T. The ton E for the metric system here is in a lowercase t. Okay, so let's convert 160 pounds to kilograms. I'm trying to go from pounds to kilograms. Pounds to kilogram conversions right here, so I can set up my unit fraction. I'm starting out with pounds, so I need the pounds to be in the bottom so I can convert to kilograms. So I'm looking at a unit fraction here of 0.45 kilograms over 1 pound, which means I'm going to start with what's given to me in the problem, 160 pounds. Now LB, that's what this is. LB stands for pounds. Don't ask me why. Couldn't tell you why they come up with LB to stand for pounds, but they did. Okay, don't know how that conversation went, but LB is the abbreviation for pounds. All right, so we're going from 160 pounds to kilograms. Starting out with the 160 pounds over 1. I'm going to use our unit conversion here. Found it from the chart back there. This is going to allow the pounds to cancel out. It's going to leave me with the 0.45 kilograms on the top times the initial 160, which gives me 72 kilograms. So 160 pounds is the same thing as 72 kilograms. Easy enough. Now let's look at temperature. Fahrenheit temperature scale. Typically we use Fahrenheit here in the Americas here, but elsewhere they use Celsius. We're gonna have to use some conversions, of course. Now with the Fahrenheit temperature scale, water freezes at 32 degrees and water boils at 212 degrees. In the Celsius temperature range, water freezes at 0 degrees and water boils at 100 degrees. Okay? Fahrenheit versus Celsius. So, we can convert from Celsius to Fahrenheit or Fahrenheit to Celsius by using the following formulas. Fahrenheit equals 9/5 Celsius plus 32, or Fahrenheit equals 1.8 Celsius plus 32, depending on whether or not you want to use the fraction. And if we want to go from Fahrenheit to Celsius, we can say Celsius equals 5/9 Fahrenheit minus 32. Okay. Let's look at an example. It says the bills from your European vacation have you feeling a bit feverish, so you decide to take your temperature. The thermometer reads 37 degrees Celsius. Should you panic? Well, we don't know. Maybe you know your Celsius readings right offhand, but like I said, I'm from the U.S. I don't know. We're over in Europe. They're reading in Celsius. We are typically used to reading in Fahrenheit, so we're gonna have to do a unit conversion and figure out should we be worried or not. So let's use the unit conversion formula over here for converting temperatures from Celsius to Fahrenheit. Okay. So we're gonna start out with the Fahrenheit equals 9/5 C plus 32 formula. Okay, I'm going to substitute in for this C here, the 32 that the thermometer read, or sorry, 37 the thermometer read. So we're going to substitute the 37 in for C. We're going to multiply it out. So 9/5 times 32 gives me 66.6 plus 32 gives me the 98.6. So your temperature is 98.6 degrees Fahrenheit, which is normal. Shouldn't be worried. We were able to convert from Celsius to Fahrenheit. 37 degrees Celsius is the same thing as 98.6 degrees Fahrenheit. The temperature on a warm spring day is 77 degrees Fahrenheit. Let's find the equivalent temperature in Celsius. So now we will use the Celsius formula here from Fahrenheit to Celsius to do this conversion. So C equals 5/9 Fahrenheit minus 32. We're going to substitute this 77 here in for the Fahrenheit F. So I'm going to look at 5/9, 72 minus 32. Remember to do the 72 minus 32 first because it's in parentheses. So that gives us a 45. 5/9 times 45 is 25. So thus 77 degrees Fahrenheit is equivalent to 25 degrees Celsius. Simple enough. Uh-oh. We've got another one here. The Kelvin temperature scale. Absolute zero is the coldest possible temperature at which there is no heat and molecules stop moving. 0 Kelvin is negative 273.15 degrees Celsius, or absolute zero. 373.15 Kelvin is the boiling point of water. So we can now convert from Celsius to Kelvin or from Kelvin to Celsius. This one's really simple here. Kelvin equals Celsius plus 273.15. Or, if we want to go the other way from Kelvin to Celsius, Celsius equals Kelvin minus 273.15. It's a simple addition and subtraction right there. So let's compare the three temperature scales. The Kelvin, remember, the top line up here is where water boils, the middle line is where water freezes, and the bottom line is absolute zero. So at 373.15 Kelvin, that is equivalent to 100 degrees Celsius, which is equivalent to 212 degrees Fahrenheit. 273.15 Kelvin is the equivalent of 0 degrees Celsius, is the equivalent of 32 degrees Fahrenheit. 0 degrees Kelvin is negative 273.15 degrees Celsius, or negative 459.67 degrees Fahrenheit. That is your absolute 0 point. That is extremely cold, obviously. And thus completes chapter 9.3. Quick one there, but you will get plenty of examples to practice for your assignment. So please go on and try those. Take your time with it, and retry it as necessary. You get a few attempts. If you have any trouble, let me know. Just doing some conversions here, and I look forward to seeing you in the next section. Reach out to me if you need me, and I will see y'all next time.